Well, hello, SL students scattered across the world. So, the first thing we're going to do is explain the midterm practice. As you know, we are going to have two evaluations on these topics, and that is to cover for the midterm that unfortunately we were not able to do. These two quizzes will be done through Quizlize. So right now, what I'm going to do is that I'm going to explain all the questions from the midterm practice. So this is question number one. Consider f of x equals square root of x, sine of pi fourths x, and g of x equals square root of x. For x greater or equal to 0, the first time the graphs of f and g intersect is at x equals 0. Find the two smallest non-zero values of x for which f of x equals g of x. So basically what they want us to do is to equal the functions and solve the resulting equation. So let's do that. Let me get my pencil here. Okay, so the first thing we're going to do is equal these equations. So square root of x times sine of pi fourths x equals, let's mix it equal sign of it, equals square root of x. Now notice that on both sides we have square root of x, so we can cancel that out. Plus that would be the first solution where they would both be 0, and therefore 0 comma 0. So we're not interested in that particular result, but we're interested in what happens if we cancel these out. Well, this becomes a 1. It would be the same as dividing by square root of x by square root of x. So we have then that sine of x, or sine of pi fourths x, equals 1. So the question is, where does sine of any angle equal 1? Well, we can think about the unit circle, and surely this is where, at 0 comma 1, that's where sine equals 1. So that means that this has to equal pi halves, or multiples of pi halves. So pi fourths x needs to equal pi halves, or multiples of pi halves. That would be plus 2 pi. So look for the first solution. Remember, this is normally times k, with k being an integer. So let's start with k equals 0. That would be our first solution. So where does this equal pi halves? So pi fourths times x equals pi halves. Where does equal pi halves? So notice that this would give us that x equals 2. The other case, we'll do it over here. The next case, because they're asking for find the two smallest non-zero values of x. So the next one would be plus 2 pi, pi halves plus 2 pi, and that is obviously going to be 5 halves pi. So for what value of x does pi fourths times x equal to 5 pi halves? And if we solve this, we can see that x equals 10. So that would be the solution to this first problem. X equals 2, or x equals 10. Those would be the first two non-zero solutions. Very well now. So we're going to work on question 1b. Question 1b, as we can see here, and let's get our marker, says the set of all non-zero values that satisfy f of x equals g of x can be described as an arithmetic sequence. Well, this kind of makes sense, because if you have an oscillating function and then another one that goes up slightly, you're going to have a lot of intersections. And it says that it can be described as an arithmetic sequence. U sub n equals a plus b times n, where n is greater than or equal to 1. Okay, so let's think about the normal formula that we have for an arithmetic sequence. Remember that we have that the nth term of an arithmetic sequence is equal to the first term plus n terms minus 1 times the common difference. Now, this is part of what the IB expects you to be able to do. Now, this formula you will find in the formula booklet, but they expect you to remember how to use these formulas. So we can say then that the nth term is equal to the first term. Now, because this is the set of all non-zero values, the first term, remember from the previous question, was 2 plus n minus 1 times the common difference. But the common difference is easy to find out because we had two values before, right? We had 10 and we had 2. So 10 minus 2, which equals 8, will be our common difference. Now we can rearrange this, multiply these two things here, and we're going to get 2 plus 8n minus 8, and this is going to equal minus 6 plus 8n. And we have our answer because this is A, so A equals minus 6, and B equals 8. And that would be the solution to question 1B. So finally, we're going to work on question 1C. And let's get our marker again, pen. And it says that at point P, the graphs of F and G intersect for the 21st time. So find the coordinate of P. Now, from the previous question, we learned that these graphs intersect forming an arithmetic sequence. And we learned the arithmetic sequence was of the form minus 6 plus 8n. Minus 6 plus 8n. So, but this was when we took 2, which was the second term in the sequence, to be the first. So that means that n, in this case, n will equal 20. So let's plug that in here. And that would be the nth term of the sequence, or the 20th term of the sequence, for n equals 20. So that would be minus 6 plus 8 times 20, and that will give us 154. 154. But they're asking us for the coordinates of P, of the point. And this would be the x coordinate. So which is the y coordinate? Well, remember that this function g is simply square root of x. Therefore, we can now conclude that the point P, let's write it as P, point P will then be 154, comma, square root of 154. And that would be the answer. Very well, so now we're going to work on question 2A. So the first thing I'm going to do is go get my marker set up, and here we go. And let's read the question. The following diagram shows a right triangle, ABC, point D lies on AB such that CD bisects angle ACB. So this is bisected. That immediately means that this angle and this angle are the same. Then they tell us that ACD, this angle here, is theta, and that AC, This length here is 14 centimeters. So let's write 14. This is 14. Given that sine of theta equals 3 over 5, find the value of cosine. Okay, I think the easiest way to find this is using the proportions, the trigonometric ratios. So let's redraw this triangle here. It's a right triangle, and this angle is theta. Okay, so they're telling us that sine of theta is 3 over 5. Sine is opposite over hypotenuse, so 3, and the hypotenuse is 4, or 5, excuse me. I'm getting ahead of myself. I'm thinking that this is a 3, 4, 5. This side must be 4. This side must definitely be 4. So now they want us to find the value of cosine. It's very easy because since we know that the proportions in this triangle are 3, 4, 5, the special right triangle, then that means that cosine of theta must equal adjacent 4 over 5. And that would be the answer. So here we are with question 2b. Find the value of cosine of 2 theta. Okay, so 2 theta. That's a double angle identity. Now recall that cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. That's one of the identities for the double angle of cosine. There's others, but we're going to use this one. So we already have the value of cosine, and remember that we said cosine is 4 over 5. So this will be 4 over 5 squared minus sine, which we found to be 3 over 5. So 3 over 5 squared, and this will equal 16 over 25 minus 9 over 25, and that will be 7 over 25, which is the final answer. So let's work on question 2c, where they say, well, hence or otherwise find BC. Now remember that when they talk about hence, it means use the previous information. Okay? So what is the previous information? The previous information is that cosine of 2 theta is equal to 7 over 25. Now cosine is the adjacent side, so this side 7 over hypotenuse 25. But remember that this is not necessarily the measurements of those sides, but it's a proportion. The proportion of cosine of 2 theta is 7 over 25. Recall that before they told us this side actually measures 14. 14. In other words, this equals 14 over the length BC, which is what we want to find. But it's easy to find because we can see that 7 times 2 is 14. Therefore, BC must equal 25 times 2, where BC is 50. Full stop. So here we are with question 3a, and let's get the marker ready. Here we go, the pen. This is one of the easiest questions that we had in this midterm practice because it has to do with inputting values in a function. So what is f of 14? Since this is f of x, f of 14 then simply equals plugging in 14 into the function instead of x. So 14 plus 2, and we're going to get square root of 16. And this, of course, is 4. Okay? Now, once we have that, we can answer this question because here they want us to find g of f of 14. Now, don't waste your time finding g of f, right? The composition of g of f, because we already know what g or what f of 14 is. This is 4. So basically, what they want us to find is g of 4. And that's going to equal 3 times 4 minus 7, and this would equal 12 minus 7, which is 5. So now we're on part 3c, where they ask us to find the inverse of g of x. Let's recall that g of x is equal to 3x minus 7. So they want us to find the inverse of this. Recall that to find an inverse, one of the easiest ways to do it is by exchanging x and y. Remember that this is the same as saying y. So let's do that. So we can say that x is equal to 3 times y minus 7. Therefore, 3y is equal to x plus 7, and then y is equal to x plus 7 divided by 3. So we found the inverse of g. So the inverse of g of x is equal to x plus 7 over 3. Okay, great. So now we are on question number 4, as you can see, and this one has to do with an infinite geometric sequence. So it tells us that the first two terms of an infinite geometric sequence are 18 and 12 sine squared of theta, where theta is between 0 and 2 pi, and theta does not equal pi. So find r. Now when they say r, don't forget that that's the ratio, the common ratio in a geometric sequence. And from the definition, we know that the common ratio is equal to the second term divided by the first term, or the third divided by the second, etc., etc. So this would equal then 12 sine squared of theta over 18. And then this we can simplify. We can simplify it as 6 times 2, 6 times 3. So 2 sine squared of theta over 3. So this is your common ratio. Okay, so for part 4b, they asked us to find the possible values of r. Now, remember that r is equal to 2/3, or 2 times sine squared of theta over 3. So you might say, what are the possible values of r? Well, it has to do with the sine function. Now recall that the sine function is bounded by -1 on one side, right? So sine of theta has to be a value between -1 and 1. And if we talk about sine squared, that will get rid of all the negative values. So really sine squared should be greater than or equal to 0, but less than or equal to 1. But in this case, they tell us that theta, the angle theta, is greater than 0. Okay, remember that sine of 0 is 0, but because it's greater than 0, then for our purposes here, this will have to be just greater. So let's erase that actually. And let's erase this, and we're going to rewrite it as simply greater than 0. Okay, so now since we have that, how can we convert this into that? Well, very simple. If you have an inequality and you multiply the 3 terms in the inequality, or the 3 equations in the inequality, then we can get the same expression. So let's multiply 0 by 2/3. That's 0. Sine squared of theta by 2/3, we get the same expression that we had. And 1 times 2/3 is 2/3. 1 times 2/3 is 2/3. So there we go. Because of this, we can say that r is greater than 0 or less than or equal to 2/3. So finally, we have this question from part 4, or from question 4c. And they ask us to show that the sum of the infinite sequence is equal to 54 over 2 times 2 plus cosine of 2 theta. In order to do this, we need to remember the formula for the sum of an infinite sequence. Remember that geometric sequence. So S is equal to the first term divided by 1 minus the common ratio. Now, we don't have to really memorize or remember this one because it's in the booklet. But what they do expect us is to know how to apply it in this case. Okay, so remember that the first term was 18, and then 1 minus the common ratio, which we said is 2 times sine squared of theta over 3. So we have to work on this in order to get this. Okay. So for that, the first thing we can do is find a common denominator here. Let's multiply this by 3, so we're going to get 3 over 3. Let's erase that for a second here. There we go. So this would be the same as 3 over 3, and let's just write it as a single fraction, 3 over all of this over 3. There we go. Okay, now this is the same as 18 over 1. Let's just look at it this way. So let's rewrite that as 18 over 1 just so we understand. 18 over 1. So 18 over 1. And remember that when we have something like this, we can simplify it by multiplying the extremes and multiplying the inside, as I call it. So 18 times 3 is 54. And then we end up with the expression 3 minus 2 sine squared of theta. So how do we get from here to what they're asking us for, which is something in terms of cosine of 2 theta? So we have to think about the double angle identities, and I think we should use the one cosine of 2 theta is equal to 1 minus 2 sine squared of theta, because it's the one that looks the most like the expression we have over here. So how can we do that? Well, we have 3 here, so we can take 1 from 3 and just rewrite the denominator here as something similar to this. So notice that we could rewrite that as 54 over 2 plus 1, which is 3, minus 2 sine squared of theta. And notice that we have the double angle identity for cosine. So this is the same as 54 over 2 plus cosine of 2 theta. And we're done. So here we are on question number 5, part A. Now this is a different type of question because, as you can see, here we have a quadratic function. Okay, so I thought about making the screen bigger. Let's make it bigger, a little bit bigger, in case somebody's as blind as I am. That's a little bit better. So let f of x equal ax squared minus 4x minus c. A horizontal line, L, intersects the graph of f at x equals -1 and x equals 3. The equation of the axis of symmetry is x equals p, find p. Okay, it's an axis of symmetry question. Now let's assume that this is what the quadratic function would look like, and this is what the line L would look like. So the equation of the axis of symmetry is the one that gives us the line that goes through the very middle of the quadratic function. So if this is line L, that means that x equals 3 here, and x equals -1. So what is the line of symmetry, the axis of symmetry? It has to be the value that is exactly between -1 and 3. So how do we find that? Well, we can find that as an average. So -1 plus 3 divided by 2, that's going to give us 2 over 2, which is 1. So P is equal to 1. In the next question, they're saying, well, hence, show that A equals 1. Let's just solve that one right here so we can see that. Show that A equals 2, excuse me. So hence, right? Now for that we can use the equation for the axis of symmetry. We call it, it's minus B divided by 2 times A. And then looking at the original equation f of x, b is negative 4, so minus b will be minus 4 over 2a. But we know that this equals 1. So let's solve this equation and we will have the value, or show that the value of a is 2. So then negative 1 times, or negative 4 would be positive 4. And let's just send the 2a to multiply 1, so this equals 2a. And then here we go, because obviously a is equal to 2. Okay, so now we're on 5c, and they tell us that the equation of L is y equals 5. Find the value of c. Now, if we remember the equation itself, f of x equals ax squared minus 4x minus c. So they want us to find c. In fact, we already know what a is because we found earlier that a equals 2. So we're just going to substitute that a for 2. So f of x equals 2x squared minus 4x minus c. So how can we find c? Well, to find c, we can use the fact that y equals c. And before they said that f of x and L intersect at negative 1 and 3. So the obvious y value at those points is 5, right? Because the line is y equals 5. So let's just substitute this in this equation and solve for c. Let's use this one because it has negative 1, and that's a lot easier. So 5 is equal to 2 times negative 1 squared minus 4 times negative 1 minus c. So solving for c, we can rewrite 5 equals 2 plus 4 minus c. Okay, so we're going to get that 5 equals 6 minus c. So negative 1 is minus c, so c is 1. So we're currently on question number 6, and this one is a geometric problem. So let's see, the following diagram shows a circle with center O and radius r centimeters. So this is the sector, and it says points A and B lie on the circumference of the circle. The angle AOB is theta. The area of the shaded sector AOB is 12 centimeters squared, and the length of the arc AB is 6. Find the value of r, find the radius. So basically here they're implying that we use these two formulas, the one for the area of a sector in a circle. So let's use that. So that's the formula says that 1/2 r squared times the angle in radians equals the area, which in this case is 12. And the other factor they want us to use is the formula for the arc length. And for the arc length, we have that r times theta equals the arc length, in this case 6. So we have a system of equations that we can use to solve for r. Notice that here we can rewrite this as theta equals 6 over r. So I'm going to plug this in to the first function, the function for the area. So 1/2 r squared times 6 over r equals 12. Now by doing this, I'm able to eliminate this r here. So I'm left with 1/2 r times 6 is equal to 12, which we can rewrite as 6 divided by 2. So 3r is equal to 12, and therefore r is equal to 4. So we're now working on question 7a. It shows us a diagram with a triangle ABC that has length AB equal to 3, BC equal to 8, and angle ABC equal to pi thirds. Show that AC is equal to 7. So we have the opposite side opposite to the angle, and the other two sides. This is obviously an application of the law of cosine. So we know that AC squared would have to equal 8 squared. Oh, wait, let me get this pen in the right position here. So here we go. 8 squared plus 3 squared minus 2 times 8 times 3 times cosine of pi thirds. So what's cosine of pi thirds? Cosine of pi thirds, remember, if you go to a special right triangle, 30-60, so 30-60, and then this side is 1, the hypotenuse is 2, and the side opposite to 60 is square root of 3. So cosine of pi thirds is cosine of 60, which is 1/2. So this is 1/2. We can substitute this for 1/2, so that's what we're going to do here. So let's rewrite cosine of 60 as 1/2. So that will cancel this 2 out. And now we're going to be left with something a little simpler. So AC squared equals 64 plus 9 minus 24. So that's going to be 64 minus 24 is 40 plus 9, 49. So AC squared equals 49. And the only solution to that is 7. AC equals 7. Why is that? Well, because, although minus 7 is also a possible solution, we don't have negative lengths in triangles. So we have proven that AC equals 7. Okay, so here we are on question 7b. And in this one, they say the shape in the following diagram is formed by adding a semicircle with diameter AC. So this from A to C is a diameter, which we found from before that was 7. So find the exact perimeter of this shape. So the perimeter will be 3 plus 8 plus the semicircle. Okay, so we know that a full circumference is diameter times pi. That's a circumference. But this is half a circumference, so we're going to have to say diameter divided by 2. In this case, the diameter is 7. So let's substitute D for 7. So 7/2 pi plus 3 plus 8. And 3 plus 8 is 11. So our final answer would be 3.5 pi, we can leave it like that, plus 11. Okay, so now I'm going to work on questions 8a and 8b. We're pretty familiar with these because we actually have already done some evaluation, and probably this question is repeated from the past, but we'll do it anyway. So it says let f of x equals x squared equal x squared minus 4x plus 5. Find the equation of the axis of symmetry of the graph of f. So we can just go minus b over 2a, make things simple. So in this case, minus 4 over 2 times 1. So this will be 4 over 2, 4 over 2, which equals 2. So x equals 2 is the equation of the axis of symmetry. Don't forget to write it in this form, otherwise you would lose a mark. All right. So let's go to 8b, and it says the function can also be expressed in the form f of x equals x minus h squared plus k. Now remember that this is the vertex form of the function. And they ask us to find the value of k. Well, h, we already know, is going to be 2, because that's the x-coordinate of the axis of symmetry. Now we can find this 2 ways. We could complete the square and put the function in this form, which I'm going to do. And then also we could just plug in 2 and find the k value of the vertex. Remember that this is the vertex form of the parabola where h comma k are the coordinates of the vertex. So let's do completing the square first. So remember how to complete the square. If we have x squared minus 4x plus a number, that will give me a perfect square. Don't forget plus 5, and then we have to subtract the same number in order to not alter the value of the actual equation or function. So how do we find this term here? Remember, that's going to be half of this squared. So half of minus 4 is minus 2, and that squared is 4. But we have to subtract the 4. So now we have the perfect square, and this is x minus 2 squared plus 5 minus 4, 1. So this would be the function, and notice that this is k. So k equals 1. Let's try it the other way. The other way is simply plugging in 2 into the original function. So let's go 2 squared minus 4 times 2 plus 5. So 2 squared would be 4 minus 4 times 2, which is 8, negative 8, plus 5, and this obviously will equal 1. So those are the two forms we can solve this. So here let's just put the answer to finish. K equals 1. Very well, so next I'm going to work on questions 9a and 9b. So for 9a, we've done others that are similar to this one, but that's okay, we'll do it anyway. So sine of theta equals square root of 5 over 3, where theta is acute. This is important. Find cosine of theta. Now, we could use the Pythagorean trigonometric identities, but let's make this simple. So if I have a right triangle, and this is theta, and they tell me that sine of theta is square root of 5 over 3, that means that this is square root of 5, and that this is 3, right? Because it's opposite over hypotenuse. And then if we do the math, this side, using the Pythagorean theorem, would be equal to the square root of 3 squared minus square root of 5 squared. That's going to be square root of 9 minus 5, which is square root of 4, which is 2. So this side here is 2. And with that, we can write cosine, because then cosine of theta will equal 2/3 or 2 over 3. So once we have that, we can find cosine of 2 theta. And like I did before, I'm going to use a double angle identity. Cosine of 2 theta equals cosine squared of theta minus sine squared of theta. So in this case, cosine is 2/3. So 2/3 squared minus square root of 5 over 3 squared. And this is going to equal 4 over 9 minus 5 over 9. And this equals negative 1 over 9. And that's the final answer. Okay, so now let's take a look at question 10. And we have it all here, 10A, B, and C. First of all, this one is only worth 5 marks because the questions are pretty easy. So g of 2. G of 2 is simply plugging in 2 in g of x. So g of 2 will equal 4 times 2, and that is 8. Now find f of g of x. Now we can rewrite this as f of g of x, or, which is the same, f of 4x. In other words, put 4x inside f of x. So that will be then 8 times 4x plus 3, and this is going to give us 8 times 4, 32x plus 3. And finally, find the inverse of f. So let's just do this quickly. So f is y equals 8x plus 3. Let's exchange x and y. So x equals 8y plus 3. So doing this very quickly, y would equal x minus 3 over 8. And this is the inverse of f. Okay, so we're down to the last question on this video. This is where I'm going to stop. We'll solve this question 11, and you will be evaluated this week on this type of question that we've done so far on the midterm practice. And we'll do another video covering the 9 remaining questions. And we'll base the second evaluation on that part of the midterm practice. So let's focus on this question. Notice that it's eight marks, so it probably is a little hard. But you'll see that it's not really that hard. Okay, so here they say, they give us f of x equals 3 tangent to the power 4x plus 2k, and g of x equals minus or negative tangent to the power 4x plus 8 times k tangent of tangent squared of x plus k for x between 0 and 1, where k is greater than 0 but less than 1. Okay, and it says that the graphs of f and g intersect at exactly 1 point. So this is the key. They intersect at 1 point. So if the graphs intersect at 1 point and we equal them, and then we move everything to the left-hand side, so to speak, and equal it to 0, then what we really need is the discriminant to equal 0, because that's when these the solution will be exactly 1. Okay. Why is that? Because I sense this is going to be a quadratic problem. You can see the pattern. So let's just equal f of x and g of x first of all. So 3 tangent to the 4 of x plus 2k equals minus tangent to the 4 plus 8k tangent squared of x plus k. So one can sense this is a quadratic deal. Let's move everything to the left-hand side. So 3 plus 1, we would have now 4 tangent to the power 4 of x minus 8k tangent squared of x, 2 minus 1, so plus k equals 0. So why do I say that this is a quadratic problem? Because we can rewrite this. Notice that we can rewrite this as 4 times tangent squared of x squared minus 8k tangent squared of x plus k equals 0. So because this has they intersect at exactly 1 point, meaning there's exactly one solution to this, then the discriminant needs to equal 0. If you remember in the quadratics, the discriminant equals 0 when you have a situation that the graph intersects the x-axis only in one given point. This is the same thing. Okay, so the discriminant, remember, is b squared minus 4 times a times c, and this has to equal 0 in order for there to be only one solution. So let's substitute everything in here. So b is this. So we're going to have minus 8k squared minus 4 times a times c, which is k, should equal 0. So let's rewrite this properly. So this will be negative 8 times negative 8, so it'll be 64k squared minus 16k equals 0. So let's rearrange this. Notice that we can factor out a couple things here. We can factor out 16 and we can factor out k. So this is the same as having 16k times, this would be 4k minus 1 equals 0. So we can see the two solutions here. One would be k equals 0, but I believe before they said that k was greater than 0. So let's look at the original problem. Yes, right here, you see that? K is greater than 0, so we don't care about this solution. We care about this one. So 4k minus 1 equals 0. Solving that, we know that k has to equal 1/4. And that would be the answer. And the end of this video.